Write each of the following sets of numbers in set builder and interval notation. So let's start with the set of real numbers that is less than 4. So let's think about a picture first just to describe the set we're looking at. So if you think about a number line, here's 4. We want the set of numbers that is not equal to 4 but just less than 4. So I'm going to think about an open circle here. I want all of those values that are less than 4 or to the left of 4. So for set builder notation, we'll use the variable x as our variable in our set. Set builder notation, since it's a set, uses the curly brackets, and then it describes what variable we're working with. So we're going to use x. So set builder notation says the set of real numbers less than 4 is the set of all numbers x such that, and then we'll use an inequality to describe this set. So we want all of those x's that are less than but not equal to 4. So this describes the set of real numbers less than 4 in set builder notation. For interval notation, we think about left to right as we picture our graph. Well, the left side, it goes off to the left forever, and then the right side, it comes up to 4 and stops. So interval notation describes the furthest thing to the left and then the furthest thing to the right. So we'll start by saying it goes forever off to the left. The way we can do that is to use a negative infinity. We always put a parenthesis with an infinity or negative infinity since we can never be equal to that value. It's not a set number. It just means goes on forever. Comma, and then the furthest thing to the right is 4. We'll use a parenthesis here to show that we come up to 4 but not equal to 4. So this first one, this is considered set builder notation. And this is our interval notation. Let's look at another. The set of real numbers greater than or equal to -2. So thinking about a picture first again. This is -2. This time we're saying you can be equal to -2, so I'm going to show that with a filled in circle. And then anything greater than -2. So starting out, we'll use the variable x again in our set builder notation. This would be the set of all values for x such that this time x is either greater than or equal to -2. So we'll write that as an inequality. This time with the bar underneath our inequality to show that we can be equal to -2. Thinking left to right for our interval notation, the furthest thing to the left that is shaded on our graph is -2, and we want to show that we can be equal to that. So we'll start with a bracket and the -2 to show that we can be equal, and then infinity to show it goes forever off to the right side. The infinity gets a parenthesis even though we have the equal sign in our inequality because we can't be equal to infinity since it means it goes on forever. So what about this third one? All of the real numbers except for 5. So if we think about on a number line what that looks like, if this is 5, we're saying not equal to 5, but we want the things bigger than 5 and the things that are smaller than 5. So when we go to write this in our set builder notation, the way that we can do this is to say that we want the set of all numbers x such that we can just describe what we don't want. X is not equal to 5. So this describes the set of all real numbers x such that x is not equal to 5. To be able to do this in our interval notation, we're actually going to need to describe the left side of the shading, hop over the 5, and then describe the right side. So the way we can do this is to go from -infinity up to 5 with a parenthesis. That's describing this side of our shading. And then we use what's called a union symbol. It's the mathematical way to say or. And then now we want to describe this side of our shading. So starting at 5 and going off to the right forever. So we do parenthesis, 5, and infinity. So no brackets since we can't be equal to 5, but showing everything to the left of 5 and everything to the right of 5. Our last one here, the set of real numbers between 6 and 10, including those endpoints of 6 and 10. So thinking about a picture first, here's 6, here's 10. We're saying you can be equal to 6, we can be equal to 10, and we want everything in between those values. So for our set builder notation, we're going to use what's called a three-part inequality to show that x is sandwiched in between these endpoints. Both of the inequality symbols include the bar underneath to show that we can be equal to 6 and equal to 10, and x is everything in between. When we're thinking about our interval notation going from left to right, the left side of our shading starts at 6 and equal to 6, so we'll do 6 with a bracket, and it stops at 10 and equal to 10, so we'll do 10 with a bracket there as well. So sometimes a picture showing a number line graph can help to get started as you're thinking about how to write different sets of numbers in both set builder and interval notation.